Okay. I've gotten to the end of the new theoretical material that I wanted to present to you about electricity and magnetism. As I mentioned earlier, when Maxwell discovered that missing term in one of the equations, I mean, this effect that nobody had noticed before, that changing electric fields cause magnetic fields, that really completed our basic understanding of how electricity and magnetism work. And Maxwell cast the whole theory, I mean, all of the discoveries that have been made by Coulomb, by Faraday, by Ampere, he cast that whole theory into mathematical form and was actually able to sum it up in, with just a few equations. And Maxwell did that in the 1860s. And since the 1860s, those equations haven't changed. I mean, our understanding of the fundamental equations behind electricity and magnetism and how electricity and magnetism operate, how they're related to, how the fields are related to the charges, both when the charges are stationary and when they're moving. You know, all the effects that we've studied for months now are summed up in those basic relationships that Maxwell came up with. And we don't know anything more about that today than Maxwell knew in the 1860s. What has changed since the 1860s, of course, is technology. People taking advantage of those basic discoveries in physics. When Maxwell did his work, there was very little in the way of electrical technology. And today, of course, the whole civilized world runs on electricity. And so one of the things I wanted to do this morning was just review some of the basic inventions that gave rise to the electrical world we live in. Primarily in the 19th century, the beginnings of electrical technology is what I want to talk about. And then I'll mention, at the end, some of the major 20th century discoveries. Okay, so, well, if you were going to make a list of major inventions in electricity, what one should go first on the list? It's one I've already presented to you. The battery, absolutely, good. And anybody got a year for that? Volta, yeah. It was Volta, and okay, 1800. 1800 exactly was when he actually published his major paper on the battery. I mean, he had been, the invention actually took several years, and he actually had his first battery, I think, in the lab in 1796 or something. But I mean, by 1800 was when his paper came out and the whole world knew about the battery. Now, this it's one of those cases where a practical invention really drives the whole history of the science. We've seen this because before the battery, the only thing scientists could study was just static currents, right? I mean, all you could do is, rub something against a spinning glass ball or something and get a static charge on it and then try to do experiments with that static charge. I mean, people had found out a lot about electricity by doing that. But static electricity is not very practical. The world we live in, all electrical technology today depends on currents, generating continuous moving electricity. And the first time people could do that was when Volta invented the electric battery. Okay, now, there is a disadvantage to batteries, though. What you're doing with a battery like Volta's is you're putting chemicals together in the right combination so that a chemical reaction takes place and generates electricity. Okay, that's what Volta figured out how to do. Now, what's wrong with that way of generating electricity? You see any disadvantages? Yeah, Daniel. Yeah, exactly. What happens when the reaction stops? I mean, it's only going to run for so long before the metal plates in your battery get, coated with the products of this chemical reaction, and the whole thing grinds to a halt. Furthermore, it's hard to produce really big currents with batteries too. So this technology had its limitations. Now, what was the next major innovation here then? Yeah, Nia. Yeah, absolutely. The electric generator. Who did that? Faraday. And what year? Give me a year. Roughly.
1830.
Wow, that's really good. Yeah. 1830s. Electric generator and motor. So the first, I mean, the key here is actually Faraday discovering in 1831 how to produce an electric current not by means of a chemical reaction like the battery, but by means of mechanical motion. Okay, so you don't need a chemical reaction at all. You take a crank and you turn it. Okay, and if what you're doing is turning, say, a coil of wire through a magnetic field, it generates a current in that coil, and you can generate quite large currents that way, depending on how fast you crank the coil, the size of your coil, so on, the size of your magnetic field. So this was the key, the fundamental physical discovery that immediately led to people making electric generators where you're turning mechanical power into electricity. And of course, it works the other way around too. You can make motors that, if you have an electric current, will cause a coil to rotate and turn a crank that can do work like pull a bucket of water out of a well or whatever. So people figured out how to go from mechanical power to electricity, and from electricity to mechanical power. And the very first generators and motors were made in the 1830s. Now, these were small in the 1830s, and they weren't, it was going to be many decades before people really figured out how to make huge generators that would then start making real practical use of electricity. But it started, that whole process started in the 1830s. Okay. Now the next invention is one that I don't think I've mentioned so far in this class, the telegraph.
Who is that?
Well, it started with a guy, Samuel Morse. And he's famous for Morse code. Remember, one of the disadvantages of living back at this time is if you wanted to communicate to somebody in a town hundreds of miles away, what did you have to do? Yeah, send a letter, absolutely. All you have to, you write this letter, and you don't sit down at your computer and type it out and edit it on Word. I mean, you write it out longhand, with a quill pen or something, and then they didn't even have fountain pens. And then you give it to somebody who puts it on the back of a horse and rides a couple hundred miles to the town that you want to communicate this to. And of course that takes a long time, and then God knows when you'll hear the reply. Well, people had the idea, once they figured out how incredibly fast electrical signals travel through wires, it was a natural for people to think, well, what if we could string wires between towns? And then what would we have to do? Well, you have to, they didn't have, of course, at this point, they couldn't send voice signals or anything like that. Either there was electricity in the wire or there wasn't. Okay, so Morse had the idea, well, we could take the alphabet, the 26 letters, and assign to each letter little like dots or dashes. Okay, depending on, and a dot would be a very short duration electrical signal, and a dash would be a longer duration electrical signal. So he took all the 26 letters and made them into dots and dashes. I'll give you an example. Let me see. The S was symbolized by 3 dots, okay? So that would be 3 short little electrical signals. And O was 3 dashes, 3 longer electrical signals. So if you were in distress and you wanted to, this was the 1840s equivalent of calling 911, would be SOS, right? That's the help signal. So you would send, if you had a telegraph office, you would send 3 dots, 3 dashes, 3 dots. Now one problem with this system, let's say you want to send, hundreds of miles. The electrical signal does diminish over long distances. And so you have, because the longer the wire is, the more resistance in the wire, right? So the less current you're going to be able to put through. So there was a problem with really, really long wires. But, Morse had the idea, well, we just have to put in relay stations. So we can't send one signal for hundreds of miles. We can send a signal, for so long. I don't know what the distance was at the time. And then we have to have in effect, a little telegraph officer and a little booster signal. So he gets the signal from the original station, and then he has his own electric battery that, in effect, resends it. But the whole thing was done automatically, so he didn't have, the telegraph station guy didn't have to do anything. That was called an electric relay. So in effect, it would take the original signal that was getting weak and resend it. So anyway, the very first telegraph line was built between Baltimore and Washington in the 1840s. And then very quickly there were wires strung across the Mississippi River and wires across the Hudson River. And by the late 1840s, they had they could send telegraph signals across the English Channel from England to France. So that was the very beginning of telegraph, electrical signals and fast communication. Okay. Well, let me tell you about well, I'll go ahead and finish up this telegraph story. The next stage was, after they had, crossing the Mississippi River, with wires was relatively easy. But of course, there was a lot of trade and a lot of communication that went back and forth between America and Europe. Stringing wires across the Atlantic Ocean was a real project. But there was a strong motive to do it, and a lot of money and effort went into it. And they this is a long, long story. It took a couple of decades, but by 1866, they completed the transatlantic cable. Actually, recently got a book on this project, which I haven't read yet, but it sounds fascinating. But this happened by 1866, I think, was when they completed it. Daniel.
How did they accomplish this?
Oh, well, they were starting to build really large ships around this time. And there was one ship that it wasn't very fuel efficient, and it was actually too large to be very practical. So it was kind of it wasn't, like I said, it wasn't really a money-making ship, but it was perfect for this job. So that was the ship that actually went across the ocean laying this cable. And then before they could do that, though, there was a guy who carried out the first survey of the Atlantic Ocean, trying to figure out the ocean depth at various places. And that was the first time that people had a good idea of how deep the ocean was at various places, was in the 1840s and 50s. And that research project was motivated by this desire to lay this cable. And that's when they figured out that there was a plateau in the middle of the Atlantic Ocean that was deeper on each side, and it was raised up a little in the middle. Troy?
So would they have relay stations like every once in a while?
Yeah, they had to have relays. I don't know exactly how they did it. I'll have to read this book that I bought. But anyway, they, by the late 1860s, you could actually communicate, America to England in seconds rather than months. Okay. Now it's worth mentioning a couple of other battery inventions. In 1859, well, I mentioned one of the things that was wrong with batteries. With these original batteries that Volta made, was that it was a chemical reaction that was obvious, that was creating the electricity, and in effect, he made his batteries with a zinc electrode, and you were basically just you were using up the zinc, turning it into zinc oxide in this process, and it would just run down and stop after a while. Now, there are chemical processes that are reversible, and there was a physical chemist, French physical chemist, Planté. I don't know exactly how you pronounce that name, but he was the first to invent the rechargeable battery. And then not long after that, only 8 years after that, another problem with batteries was solved. Remember how Volta made his batteries? He would use metal plates and in between the metal plates he would have some acid or salt solution, okay, which means he has to have a liquid in his batteries. Well, one of the problems with having a battery that's full of, say, sulfuric acid, is that it can, spill on you. And people were constantly. It was hard to make the battery really practical, as long as it had all this liquid sloshing around in it. Now, in 1867, another French physicist made the first dry cell battery. And his name is Leclanché? Who knows? I'll just, you can struggle with the pronunciation. I will spell it. Leclanché. Yes?
Like, how did he have it dry? Just by
Oh,
using
he managed to replace the liquid with a paste. So he just, basically what he did was he fiddled around with the chemistry until he found a I think it was some kind of ammonia paste that would work, that would still drive the chemical reaction, but replacing the liquid with a thick enough paste so that you wouldn't have to worry about spilling. And yes.
Would the battery be the same strength, or would it be stronger or weaker?
He could make the battery just as strong in the dry cell. I mean, of course, and this is what we have today all the time. There's no liquid in the batteries that you go out and buy in the store. They're all, dry cell batteries. Okay. Let me. Oh, where's the? Wondering where my eraser is. Okay, then major invention, 1876. Does anybody know a major electrical invention that happened in 1876? Dan?
The telephone?
Got it.
Alexander Graham.
Yeah. How did you know that?
Got lucky.
You got lucky.
I didn't know Alexander Graham Bell.
Yes, he did. Alexander Graham Bell. We're going to abbreviate him AGB. Yeah, he invented, I think in class one day I actually briefly described to you the way that Bell's telephone worked. Remember, it has a very, very thin little metal membrane that vibrates in response to the sound waves. It's got a magnet, an electromagnet underneath it, and that vibration slightly changes the magnetic field in that coil, which gives you a varying electrical signal that varies just the way the pressure of the sound wave varies. And of course, so that's the receiver, and then the transmitter works the exact same way, where you're just turning the electrical signal back into sound waves by shaking the little iron membrane over the magnet. So that was the first telephone. Now there's a story, I don't know whether you've ever heard the story of Bell's invention of this. He was working with his assistant, who was named Watson. Seems like assistants are always named Watson. Basically, if you're named Watson, there's a really good chance you can end up being somebody's assistant. But anyway, they were in different rooms, and they were going to test this telephone that Bell had made. And just as they were about to start the test, Bell had an old-fashioned battery that had sulfuric acid in it, and he spilled it on his pants. So the very first telephone transmission was, "Watson, get in here. I need your help." Or at least Bell claims that's what he said. "Watson, please come in here. I need you." You can imagine, though, that if he spilt sulfuric acid on his pants, he might have expressed it a little more colorfully than that.
So it's the first 911 call.
Yeah, right. Okay, so that was 1876. 1879. What was invented in 1879? Yes, Kyle.
Ford, he made that car.
Oh, no, that was later. Somebody, his name starts with E, made a really important invention in 1879. Any idea?
No.
Okay. Um,
Light bulb?
yep. Um, Now, Edison, Edison had been working on this for a while. It was known that if, obviously, if you put electric current through something, it heats it up. That's one of the effects that electric current had. Now, one way to, it would heat, the wire would heat up even more if you, well, if you tried to force more current through it and you made the wire thinner. Okay? It could get really hot. Now, it was also known that if you made something hot enough, it would glow, right? So you could get light. So the idea was, I mean, so far, pretty simple idea, right? All you have to do is take some thin little wire of something, force a lot of current through it to the point where it heats up so much that it puts out an intense light, and you've got an electric light. Now, what's the problem with that, Nick?
Doesn't that require immense amount of current?
Well, it doesn't require an inordinate amount of electric current. It turns out it does require that you make the wire really thin. The problems they had when they first started trying to do this was, well, first, the thing heats up so much that it starts burning and it destroys the material. Okay, now, how do you stop that? Nick?
You put it in a vacuum with no air.
Exactly. You get rid of the air so it won't burn. So that's the whole point of the bulb, right? There's no air in the bulb. So you've created a glass bulb with a vacuum in it. Now, so you got rid of the burning problem. Now, what's the other problem? What else is going to happen when you heat this thing up to really, really high temperatures? Evan? Yeah, it can melt. Most materials will. Okay, so that was a major, major problem. So Edison actually, it took him years going through every material he could think of before he finally found a material that that actually worked well enough so that he could, patent this invention. Now, his first material was basically a carbon filament. He took some, what was it, cotton thread, basically, and burned it. And the result was basically a long, thin piece of carbon. And he found that you could heat carbon up to really high temperatures without it melting and disintegrating on you. So his first light bulb had a carbon filament and it was capable of about 40 hours of operation before it burned out.
Is that like non-stop operation?
Yeah, yeah. And people recognize very quickly what an important invention this was. You think about what it was like to live back at this time. I mean, when the sun went down, people didn't do much after the sun went down. I mean, at least not much that couldn't be done in the dark. The world got dark on you as soon as the sun went down. Whereas today, we just take it for granted that there's lights everywhere, and it's people do all sorts of activities at night that require all those lights. But things got really quiet and dark when you didn't have sunlight prior to 1880. And so when Edison, the way he demonstrated this new invention of his to the world was on New Year's Eve. He had his research, like his research labs in Menlo Park in New Jersey. And the main street of downtown Menlo Park, New Year's Eve, he had made a bunch of his electric lights, and he lit up the downtown Main Street in Menlo Park, and that was the 3,000 people gathered for this amazing event, to the first large-scale demonstration of electric lighting. Okay. Now, another landmark in the history of electricity happened in 1896. Any ideas on what that might be? Troy?
Motion picture?
No. Edison was inventing motion pictures around this time, but I have something else that was a lot more important in connection with electricity. Daniel?
Radio station?
Oh, you're actually you're close in timing. I was going to talk about that next, but this is what I have in mind here. 1896 was the year the first major electric power plant went online, Niagara Falls. So, and of course what they were doing, well, why did they build this power plant at Niagara Falls? Is it just because they liked the scenic beauty, or Daniel?
Because of all the water rushing down is a great massive amount of power.
Yeah, what would they use the water for?
They would turn wheels
Yep.
really fast and electricity.
Yeah, you force all this falling water through to turn these giant wheels that are attached to giant coils that are turning in a very, very strong magnetic field, and you get out huge amounts of electricity. So this is exactly, physically it's exactly what Faraday did in the 1830s, right? But now it's being done on an enormous scale. And of course there's all kinds of engineering problems that come up when you try to take Faraday's idea and generate an enormous amount of electricity in a way that is cheap enough to make it practical. And this was the first time people had solved all those problems. And the first modern power plant basically. And the basic ideas behind power plants, haven't really changed since then. I mean, people have gotten better and better at at the engineering, but they knew the physics back then, and they it's always the same thing in a power plant. You find a way to turn these giant wheels, these turbines, as fast as you can. If you can do that, you can generate lots of electricity. Hydroelectric plants, of course, water is doing the work for you. Nuclear plants, what's happening? Troy?
The heat heats up water, which makes steam, and then steam turns the turbines.
Exactly, yeah. All that's happening in a nuclear power plant is you're using a nuclear reaction to generate an enormous amount of heat, which you can use to create steam under tremendous pressure, which will turn these huge wheels again and make the electricity.
Is Hoover Dam a power plant?
Hoover Dam is a huge hydroelectric power plant, and I strongly recommend that if you're ever out that way, you go visit it because it's a great thing to walk through. I mean, I actually wish that we could. I don't think they do tours at Diablo nuclear power plant, but if they did, I would love to take the class to go see that, but I suspect that's impossible. Okay, let me well, let's I want to list one more here. I don't really have time to talk too much about it, but 1906 is usually considered the year that the radio was invented. Does anybody know who did that? It was an Italian by the name of Marconi. Let's see. We've seen the invention of, the first invention and detection of radio waves by Hertz. And people immediately realized, well, if you can send basically electrical signals through the air, you don't even need a wire. Okay, this is going to save a lot of money on wires. For communication purposes. So, after Hertz published his research on these electromagnetic waves that started out being called Hertzian waves, but then people quickly switched to calling them radio waves. They saw a real possibility of communicating via these waves rather than just sending electrical signals through wires. And I'll tell you more about that this afternoon.